All right. Welcome to the April Alberta Passive House Coffee Talk. My name's Frank Crawford. I am the Education Committee Lead with Passive House Alberta. And today's presentation will be from Kim Walton. I'll let her do her full introduction, but she is currently a board member of Passive House Alberta and a certified Passive House designer and been a green practitioner for a long time. But before I throw it over to her, the next coffee talk will be with Silex Windows in 1 month's time. So hopefully you can join us again for that one. And please do take a look at the Passive House Alberta membership options. That helps us continue to do all the work that we are doing. So without any other further delay, I will pass it over to Kim Walton to give her presentation for today. Kim.
Hi, everybody. So I'm going to help you make your passive house dreams come true. I wouldn't mind to know when I'm done the presentation why you're here. Maybe I can focus some questions, some of your answers, the answers to questions when we're done presentation. So I'm going to continue on with my presentation. So make sure this is not working. Great. Okay. Lovely. Sorry about that, you guys. Frank, it was working and now it's not. There we go. Okay. It's just me again, and I live northwest of Calgary, and that is not working. Okay, here we go. I live northwest of Calgary in the Bearberry Valley. So I live at the bottom of Hill 12. This is the top of Hill 12. I live at the bottom of the Hill 12, and we can see we're very close to the foothills in where we are. We love where we live. It's a rural area and very sparsely populated. Okay. This is the funky house that we live in. We've been here for a few decades. This is not a passive house, not close, but we're working on making it that way. I've been doing this for a long time, as Frank said, doing sustainable design work for about 4 decades. It's a picture of me extolling the virtues of built-in or integrated greenhouses once upon a time. I am a member of the board of directors for Passive House Alberta. I'm the treasurer. I'm the president of Passive Buildings Canada. I'm a member of Passive House Canada. I am also a certified designer and certified builder for Passive House. So what is a passive house? I'm going to go through this very quickly for those of you that don't know, and some of you may know. This kind of building was started in the late 70s when we were running out of oil and gas, which seems like a fantasy at the time now, but at the time, the idea that there would be no oil and gas and that people in Canada were going to get pretty cold made the federal government step up and fund some research projects. And one of them was a Saskatchewan research house. And that was the inspiration for developing the Passive House Institute. Dr. Feist came to Saskatchewan to learn a lot from the engineers that worked on that project, and developed the Passive House standard based on Canadian technology. There is 2 Passive House standards that we might use in North America. One would be from the Passive House Institute. The other is from the Passive House Institute US. Right now, without getting too technical or wrapped up in what the difference is, they're both about building better and building really well-insulated houses to a certain standard. The next slide is just about the 5 principles of a passive house, which when incorporated all together ensure greater comfort and health and energy savings. That is our goal. So the very first principle is a lot of insulation. And just like your hat and mittens and toque in the winter, keeping us warm, keeping the inside of the building away from the environmental what's going on outside. So the same thing happens in terms of when it's hot outside, works like a thermos, the opposite. Air tightness, this also is critical for making sure that these buildings perform well. Being airtight means that we can manage and control the ventilation. Thermal bridge-free construction, what that means is that things are not, building components are not moving from the inside to the outside. They are the insulation is on the outside, and the structure is on the inside for the most part. And you can see the difference between a thermal bridge-free building, which is the blue building on the right-hand side, as opposed to the building before it was well insulated, which is on the left-hand side. Then windows. Windows are a very, very important component for these buildings, so much so that that I can't stress how important a really good window is. They are expensive, but they also will last the life of the building and probably outlive you. And then there is ventilation, and ventilation is an important aspect of these buildings, but we're not talking about huge fans or exhaust fans. We're talking about small units that don't use a lot of energy, but bring fresh air into the building, and managing fresh air within a tight building envelope is really important. So the big deal about doing a passive house or doing a building that is well insulated and has good ventilation is that we minimize the amount of mechanicals that are needed. So this illustration just shows how once upon a time, humans didn't use a lot of energy, but once they started enclosing spaces, they found that they were cold, so they needed to condition the inside, and then conditioned space became what buildings were all about. But passive house is going backwards a little bit in just thinking about the environment, thinking about the building envelope and what's surrounding you, and minimizing the amount of mechanicals, taking advantage of the sun, taking advantage of breezes and those kinds of things. That's your quick pH primer. So I'm going to run you through a few steps for you and for anybody who's thinking of building a passive house to be successful at building a passive house. And these steps, about 4 of them, are just about how to approach the building. I'm not giving you solutions because there's a lot of solutions, a lot of ways of getting there, but really more about the approach to approaching a project and approaching how the project will be done. So the first step is commitment, and that is super important in order to be successful. We can't, unfortunately, just go out and buy a passive house. There are no, especially in Calgary right now, there are no builders that are just building passive houses. The market's not there yet, but it's coming. So we have pre-built passive house dreams which don't exist. So for the most part, if you're thinking that you'd like to have a passive house, you are going to be either building a new house or you're going to be renovating an existing building to passive house standards. I'd like to show this picture because this is a passive house, and this picture doesn't tell you very much about the house except that it has a nice kitchen. So I wonder what you think. Do you think any of these are passive houses? The reason I'm showing these, it's kind of a joke, is just to say that most people look at houses and the first thing they want to see is the kitchen. They're thinking of an open floor plan and they're thinking that they'd like these finishes. And this is not at all what passive house is about. It's not that they aren't passive house or couldn't be passive houses, but this is not what the focus of passive house is about. The focus is about thinking about the whole design process and the building as a whole, and what that means in terms of getting to the open kitchen. So this is just a flow chart saying, there's a lot of steps in order to get to that pretty picture of the kitchen. By the time you're at that point in the building process, you've gone through an awful lot of work to get there. So building a passive house is a process, and not only is the building envelope different, but the approach to planning and construction is very different. And that means that as the owner and or the builder, your commitment to the passive house goals is a secret. That's the secret to the success of the project. And the team effort is going to be led by the owner and or the builder, the person paying the bills. So step 2 is to assemble a team. And this is pretty important stuff. So who's the right people to put on the team? For a typical construction project, a design team is selected by maybe, first of all, the owner might have a plan in mind, selects a designer or architect based on prices that they get, some economy. They might engage professionals, they bid on the project and they take the professional with the lowest bid. They develop plans and then they select a construction team also based on the lowest bid, and the trades for that general contractor are also based on the lowest bid. This is the perception of getting the best bang for your buck, and for the general contractor to make the most amount of money that they can for the project, which doesn't at all speak to building better or ensuring that the building is meeting goals and energy efficiency. So for a passive house project, finding and sourcing the team is quite a bit different. So first of all, there's the commitment by the owner or the builder. And then the architect or the designer is selected because they have experience with passive house or building better and or common goals to the owner builder. It's really important to engage a PH consultant in order to do this kind of project. And that consultant needs to be engaged early in the process because so much depends on ensuring that the modeling is done, energy modeling is done, and predictions for the how well the building will perform in the end are done early on. A civil engineer is selected for their willingness to be open-minded. That is an important aspect. So there's some parts of the construction and the way that the building would be built or should be built that might suspend some of the comfort level of a civil engineer, that they need to understand the reasons for thermal bridge-free construction in order to have a successful project. Mechanical design is really important, and mechanical designer and or engineer needs to be willing to design for a low load building and not over design for making sure that their butt is covered, but making sure that they understand that the way that this building is performing. The general contractor should be selected because they have passive house experience and or they have attention to detail. So just having attention to detail, that kind of a contractor is the one you want on site, somebody who's really concerned about the building, not necessarily just about making money. It's not about not making money. It's about being concerned about having a successful project. And the same goes for the trades. They're selected because the general contractor trusts them, knows that they will do the work that they're asked to do, and or they have passive house experience. So all of these things are counter to how a typical construction project would be organized or how a team would be selected. So the next step, planning. And so with a typical construction project, the design teams and the consultant teams and the construction team are all siloed. In other words, they do their work, then they pass it off to somebody else who passes off to somebody else, and they just get their work done. So they expect that everything that the design and team had done is exactly right, and that's how it will be done. And if there are any mistakes, then there's a lot of blame, and then there's a lot of there's no problem solving necessarily going on, or the issues are not taken care of during the design or the construction process. But with a passive house project, everyone is on every team. So some will be more involved than others, which makes sense because the owner is not necessarily going to be doing the plumbing, but the owner might be concerned about and visit the site and see that there's a hole somewhere that it shouldn't be, or there's some water line that has that doesn't have insulation on it that was missed, or during the process, the planning process, the plumbing trades might be involved with some of the planning just to help understand how thick a wall might want to be, just in order to get a vent going through a wall. That the framers might want to be on site, or in meetings during the planning, to say we need thicker walls in order to accommodate certain doors, or this would be much easier to frame a certain way. There's a lot of information that everybody can share to make the systems work better when it gets to the time to construct the project. So an integrated project delivery is what this is. So this little illustration is just about the information sharing, about how we might make some assumptions, just especially because we do a trade and we are a trade, or we do our own work the way that we normally do it, and we might be swayed into doing something different or better by somebody who has to execute what we're planning on doing, or somebody who has to execute it might have to think about doing something a little differently in order to meet the goals and objectives of the project. So more time planning at the beginning of the project means less labor time and less cost in the delivery of the project in the end. So step 4 is eye on the goal, keeping in mind what is going on, or what the goal of the project is and what that looks like as the design moves forward, and even as the construction moves forward. So some of the planning might even start beforehand in selecting a site, and the site selection is important, but both of these buildings are passive houses, and they're not on ideal sites. They are successful passive houses, and they work really well, but they use some of the opportunities that were less than ideal in order to gain solar access, and also to take in views in these locations. Keeping the project simple is really important in terms of saving money. There's less details required. And these are pretty boxy examples of passive house buildings and successful passive house buildings. But there are some examples of buildings that are more creative. And these aren't necessarily a lot more expensive. They just had professionals involved that could see how this could look different than just a box. So focusing on what is necessary is an important part of keeping the project on task, meeting the goals, and also keeping on budget. So building envelope, so these photos are showing, some things that are going to get buried beneath the siding, can't see what's going on later on. These are really important aspects of building better. And the ventilation system, with putting some money into a ventilation system that's very efficient, is going to mean that the building will be closer we'll be able to get closer to net zero. And it also means it's not just about comfort, about noise pollution in the house, because the better the equipment, the quieter it is. And again, putting money into windows, can't stress that enough, super important part of building better. So avoiding unnecessary things that are budget, again, complicated mechanical systems, which tend to happen often for no reason at all, except that sometimes a client really wants to have something like radiant heat, or they want to have a geothermal system or a fireplace. It's not that you can't do these things, or that you you just don't have to do them. So these are things that are not needs, they're wants, and they may actually end up costing more busting the budget for the project. Okay, And I think this is supposed to be step 5. So my bad. I had 5 steps instead of 4. So keeping your eye on the what we're trying to do. This is such an important part of making sure that we're all in it together. So during the construction, the importance of working together is really key to the success of the project. And that means that the construction agreements are fair. So the construction agreement, the contracts between the owner and the general contractor under the trades they need to be clear in that the owner is not being penalized for building better. In other words, just because the owner is making decisions that are based on building better, they shouldn't be paying more for that. They should be paying something that's fair. Also, the contractor and the trades should be paid fairly for doing their work well and for their diligence at doing their work well. So that doesn't need to turn into something that's about conflict. It does need to become something that everybody understands right up front, and that those agreements are worked through before work begins. And this also means that problems are worked out and solved together. So we're all human. Sometimes mistakes happen. We also are working in a construction environment, which means that all kinds of things can happen between rain and snow and wind. And when there's problems on site, it's great when everybody's on the same page to say, this is a problem, this is how we're going to solve it, this is the best way forward. That is one of the ways of making sure that we stay on budget and also have a successful project. So the point of PH construction is not to certify, not necessarily, although that's a great thing to do. And there's some arguments for doing that. But the real reason to do this is to build better so that we're using less energy and that we have a bit more comfortable and healthy, robust house and buildings, and that the cost of heating and cooling is minimized. So that is helping not only ourselves and our budget, but also helping our planet and helping everybody in the end. And lifetime maintenance costs are minimized because the buildings are built in such a way that they are robust and will stand the test of time. So it's the goal that counts, and what is needed in order to meet those goals is a client that's dedicated to the cause, an understanding by the client that the upfront costs will be substantially more than normal, and that this will save money in the end during construction, and that a passive house consultant is engaged, and the energy model drives the design and the budget decision making. Really important stuff. Everybody that's involved at the project is at the table, and that everyone is committed to the results. That means the project results, and the project lead needs to understand and speak the jargon. So if the owner or the builder is not able to do that, then somebody on the team needs to be that person that speaks the jargon. And the project participants are thinking beyond their own anchoring basis. So it's really just thinking outside of what they normally do. They may be pushed beyond their comfort boundaries, but that is an important part of moving forward and learning and doing better. So I stole a couple of things from another presentation I did because they seem to work. And this is one seems like a big stumbling block, which is why I included it. So a myth that my builder won't be able to build like this. And so that is actually not at all true. And I've certainly gone through projects with people who've never built passive house before, and we've gotten through it no problem at all. Having one member of the team with some passive house experience is great. That helps the entire team, and that you would lean on that person. But this building was built by a developer that had never built a passive house, did not have anybody on their team that knew anything about passive house. And what they did was they were mentored by an experienced passive house builder during the process. Mentor was not part of the building, but was called on when they, as for advice. There was a passive house consultant on the project that had no experience with passive house, which happens. And this was a very successful project. This builder's gone on this is a renovation, this particular project. And this particular builder has gone on to build 3 more passive house buildings for low cost rental at low cost rental rates. So totally fine and totally capable of doing that. The other myth is that Passive House is a boutique product for the wealthy, and that is not true if the projects are managed carefully. So these houses are in Nova Scotia, and they are built at the same cost as code-built houses in Nova Scotia. Might not be as easy to do in Calgary as it is in Nova Scotia, but the fact is that that is what these houses are, and it's been repeated many, many times. They are simple houses. They are not complicated, and that house plan is repeated, and those things save a lot of money in the end. So one more slide, just to say that this is an older slide, so the numbers here aren't quite up to date. That's about yesterday's electrical rate, but there are initial costs. They may not be offset completely, and you may not be building a custom project at the same cost as a code-built project, but over time and with utility savings, there will be a positive. You will come out ahead where you're not paying any utilities and not any mortgage, and you'll be living free in your very comfortable passive house. Okay, so I've just got a last slide here with everybody's logo, and just a reminder, just like Frank was saying, to become a member of Passive House Alberta, it really helps with these education efforts and helps us spread this information to everybody. So thank you. Now I'm going to stop sharing.
Thanks very much, Kim. Yeah, it was excellent presentation. Lots of good information there. There's about 3 questions that were sent in beforehand, but I guess before I read through those, does anyone on the call right now have any questions for Kim? You can either type them in, or you should be able to unmute yourself and ask it. If not, I'll kind of bring up some of those questions that were sent in beforehand.
I have a question, if I might.
Yep, go ahead, Mark.
Can you hear me? We actually joined the meeting late, Kim and myself. The meeting's being recorded. Is it possible to come back and watch the whole presentation? For example, Kim Walton's presentation.
Yep. Yeah, I believe they will all be going up. I believe on our YouTube channel. It just takes us a little while to clean them up and get them put up there. So yes, all of the coffee talks will be going up for viewing, reviewing shortly.
Super. Thanks.
Okay. Any other questions, you guys?
I guess we could talk. Yeah, one of the ones that were sent in before was kind of talking about barn dominiums, where you kind of have different of uses.
Oh, is that you? Okay.
Yeah, where you have kind of your main floor might be a shop or an office or something, and then you either live above it or live adjacent to it, but it's all within kind of the same building envelope. I've seen a few of those. So yeah, maybe Kim, you can give your answer, then I might add on a bit.
Well, any building can be a passive house, and so it just takes planning. So and it's the more odd a building is, the more difficult it becomes. That and then for isolating one space from another, that also just makes things more complicated. But it's not impossible to do. It's the second time this week I've heard of barn dominium. I had not heard about it before this week, so that's the second time. So it's not an impossibility. It's something that can certainly happen, and when you're planning beforehand, it might look a little different than a normal pole shed. It might there might be some techniques that might be used slightly differently, and it doesn't mean that you can't use your pole shed builder. It means that we would have to talk them into doing some stuff that they wouldn't normally do.
Yeah, I guess kind of to add on to the main things you'd have to worry about is with any passive house building, one of the most important things is setting where your building envelope is. So what is inside my building envelope, and that's the air that I'm conditioning, and what is outside that I could be conditioning, but maybe not to the same extent. So with your barn dominium, depending where your office like an office, you would probably bring it inside the envelope. But if you have like a big overhead door that goes into a shop, you might want to leave that outside the envelope, and then you just condition it kind of more sporadically or not to the same level. And yeah, with the pole sheds or the post and beam, kind of your typical farm building, the biggest thing is the air tightness and watching the thermal bridging of the various members that go from the inside outside. But yeah, can be done. Actually, if you look at 475 Building Supplies YouTube channel, they have a good example of how you can do it. It was done, I think, down in New York. So yeah, it is definitely becoming more not prevalent, but it is definitely coming up more often as the kind of the work life balance or the work live balance is coming up more. Right, Zirong, you had your hand up. Apologies if I mispronounced that.
Yes. Hey, Frank, this question is for Frank. A few years ago, thank you for organizing a tour to your house. I really like your house. So my question is, when you build your house, what is cost for square feet? And if you build it now, what is the cost now?
So when I built it, so I guess the first thing you have to decide is whether or not you're using your above grade square footage. That's what shows up kind of everywhere else in the real estate industry, because I guess it kind of assumes that your basement is unfinished and uncomfortable and somewhat uninhabitable. So if you use just above grade square footage, I was about $340 a square foot. My basement is a secondary suite, so it is definitely habitable, occupied, and there was some cost to do that. So if I go developed square foot, it was like $200 a square foot. Kim, you can probably chime in a bit. If you're somewhere between $250 to probably $350 a square foot is what you'd be building a passive house now for. Obviously, that's a big range, but that's because it depends a lot on the size and the orientation. And
those numbers are not any different than if you're doing a custom build.
Yeah.
So if you're doing a custom build, those numbers are going to be the same. It's a reality. You can't, even if you're doing a code built, custom built, because everything is different and new than if you're a track builder. So if a track builder is building many houses that are exactly the same, there's a lot of cost savings in doing that way. So $250 a square foot for anything. That's really a bare minimum. And what Frank is saying about the conditioned square or the conditioned or finished square footage, because sometimes that's going to include a garage. Garages aren't free. I think everybody needs to understand that, whether they're part of the passive house or not, and they're attached, you don't just add a garage. They cost some money. So that's a budget buster in my mind. If they're attached to the house, they require insulation, they require drywall, and they cost a lot of money. If it's 1,000 square feet of conditioned, often conditioned or semi-conditioned space.
So I guess one way you can look at to kind of reduce budgets is find some of these builders, like Collective Carpentry is starting to come out with pre-designed plans. Passive Design, is that the name from Nova Scotia? They have a number of pre-designed plans. Like you can try to beat down some of the upfront design costs by reusing a design. Not everyone needs to live in a cookie, or not everyone needs to live in their own custom house. Everything else we are getting used to buying from a set list, or from a kind of brochure, or from a set list of items. So the more we can repeat things, the faster the costs come down.
So Frank, would somebody be able to buy the floor plan and the plans for your house if they wanted to repeat your house?
Yep. Yeah, I think I had someone do that a few years ago. So yeah, I would be willing to sell my plans, and hopefully most of the other builders would as well. And definitely the details, that's the advantage of using an experienced passive house builder and a passive house designer, is they've already worked through all the tricky parts of the details. They know what works. So just use that again, repeat. Don't come up with everything new.
That does make a difference.
Yeah. Okay, thank you, Kim. Thank you, Frank. Yeah, good.
Emil, did you wave your hand?
Yes, I did. I had a question regarding windows. That's always been a problem for us, is to find windows that were good even before aspiring to this standard. And where are we with that in Canada? Most of the builders I know are importing theirs from Austria or Europe somewhere.
There are some very good windows from that come from Europe. And if we're looking for cold climate windows, that is where they come from. There are Canadian distributors for those windows, but Inotech now has a cold climate product, and that's something that can be used. But there are other domestic manufacturers of windows that can be used. Coldtech is one being made in Edmonton right now. They're not for cold climates, but you can make them work by if that's what if you're looking for something that's close to certification or is certified, you can make cool climate windows work. There's some effort in the installation, over insulation. That's where the people who have experience, or your passive house designer and or analyst or consultant can help you with those kinds of details and getting a window that is not as up to cold climate standards working in our climate.
I've been using double insulated steel doors as an alternative to the passive certified doors that seem unavailable here. Anybody else doing that with?
Well, Cascadia has some pretty good doors. They have pretty nice doors, and so does Duxton, and Duxton's doors are pretty good, and Silex has some awesome doors too. Those are domestic products. So you pay for more expensive doors and for multiple locking systems, but all of these people have something like that.
And with the doors, hopefully you only have one or two of them in the house. Mm-hmm. So you can, like, again, a certified passive house door won't make or break the project. What I kind of say is buy the most cost-effective multi-point locking door. That multi-point locking is where you get the air tightness. You just have the deadbolt hanging in there. That the door is actually going to be similarly insulated to the passive house doors. It's just going to leak a lot more air. So you can either have to make up with that by putting a little heater by the door. Yeah, like certified passive house doors can be $2,000 to $5,000. Uncertified doors can also be $2,000. So doors can get expensive. So try to limit to yourself to one or two doors. Don't be putting 3 or 4 doors into your house. But then if they're not perfect, it won't kill your whole project, because the total area versus the rest of the building is pretty small. It is a thermal bridge, but it's a thermal bridge you can kind of deal with. But I guess as a personal experience, I put in like a code minimum door, or not even a code minimum door. It's $200 to put in the door to my house. So from an energy perspective, the 2,000 door will never pay back. But from an operational standpoint, because I don't have a lot of energy wasting and leaking through that door, the lock frosts up in the winter. So I've had to go through a few different locks to find one that will continue to work in the winter. So
but
that's why
you've air sealed it, right, Frank? You've just air sealed the heck out of it, and it's
as best as you can. Yeah. But because I only have the deadbolt in the middle, if you put more air sealing all around, you can still twist the whole frame. So that's why if you get a door with multi-point locking, and multi-point locking is just where it has multiple points that when you turn the handle, it sucks it in. So yeah, basically it's buy the best doors and windows you can afford. And with doors, minimize the number of them. Get yourself down to maybe 1 or 2.
Skip the fireplace, get the windows. The list that's written here is good, except Westech doesn't, as far as I know, deliver windows to Alberta anymore.
Oh, they stopped.
Fenster would be one that's a West Coast window manufacturer, wood windows. They're on the island, and they use wood from the island, so local wood. local wood window manufacturer.
That's an interesting name, Fenster. It means window in German.
Mm-hmm, mm-hmm,
Yeah.
mm-hmm. Yeah, when I first saw them, I was sure they were German windows. They use great hardware, and they do have a good selection of windows. Again, cool climate windows. They're triple glazed, but their frames are not as good as some of the European ones.
Okay, one of the other previous ones, are there currently any financial government incentives for people to build passive house?
No.
Yeah, short answer is no. There's some of the cities, like Edmonton, has a few incentives to get to net zero. So net zero is I guess a standard that you can strive to, and you can use passive house and put some solar panels on it called Passive House Plus. That's a way to get to net zero. So right now, most of the funding is more for net zero, but you can still get passive house and still make those requirements. Hopefully more is coming out. There's been talk, but the talk hasn't transferred into actual programs yet, except in Edmonton and a few other jurisdictions.
Yeah, and some places in BC, there's some incentives. In Vancouver, there's incentives to build passive house to passive house standards. So, there's starting to be in Southern Ontario as well. So it's coming. It's certainly not in Alberta.
Go ahead, Emily.
Jonathan has a good question. I'd like to answer this because it's not that vestibules are bad. They take up space. And if you've ever heard of the passive house Subaru dealership in Red Deer, it's a good example of this. When you open and close the door really fast, or even if you just do it in a normal way, not a lot of cold air comes in. It's when the door is left open that it's a problem. So the vestibule can be dropped. You don't have to vestibule something unless you think that the door is going to be open for a long time, or on a regular basis for a long time. One of the strategies is if the cold air rushing in is a concern, is to have a wall directly opposite the door so that the air kind of hits it and goes back out. That's a theory but it's kind of works. What happens is the cold air doesn't migrate into the house. It kind of sticks around in that space. So it doesn't have to be necessarily a vestibule, but a wall that is opposite the door. Does that answer your question, Jonathan?
Yeah, and I guess also I could add on, for commercial buildings, vestibules are much more prevalent for that same reason that Kim said. They're not needed in houses. In commercial buildings, those doors are opened a lot more often. So you do normally put a vestibule. The other reason you often use a vestibule is getting passive house certified doors with panic hardware and fob hardware and all the other stuff is nearly impossible. So what they do is they make the operable, or the panic hardware and the fob, the vestibule, and the vestibule is outside that building envelope I talked about before. So that's where you can do all your access control. And then the inner door, where your building envelope starts and stops, that's your passive house door, and it just gets basically opened once a day so people can go in and open it, and then at the end of the night it gets locked. Yeah, same thing with vestibules. You're right, you don't open the door enough to really justify it, justify the cost.
So Tom has an awesome question about net zero. So I know this is all very confusing, but to simplify it, there are two ways to get to net zero. One of them is to throw a lot of PVs, so something that generates electricity on a building, and the other is to do a building envelope first. In other words, reduce the amount of energy that's needed, and then put a few PVs on a roof or near the building. So the differences are that the building itself, if it's built to passive house standards, is comfortable to be in, healthy to be in, all of those things. Plus, it's a lot less expensive to put PVs on the roof to get to net zero. So net zero really means that the building or the is generating as much electricity in a year that it needs to both heat and cool and also for all of the base loads and things that are going on in the building within a year. And that's usually the calculation. Anything else to add? Did I forget anything, Frank?
No, yeah, the
No.
passive house is what we say is passive house is one of the easiest ways to get to net zero. Passive house has a certification called Passive House Plus that is essentially equivalent to net zero, but we want to focus on the envelope first to make sure you get the comfort and the durability and the long-term lower utility bills, and then put on some solar panels. Because yeah, otherwise in theory, any acreage could be net zero ready. You just might need the whole like few acres of solar panels to offset your total energy.
So Jonathan said that little children often open and close doors slowly. You know, when I had small children, I put closers on the doors so that they didn't have to remember to close it.
They also grow out of that, so it's
They do, yes. Mm-hmm.
All right, any other questions?
Is anybody here thinking that they want to build a passive house one way or another? Did this presentation make it seem like it was more likely that you could? No answers. Nobody's stepping up.
I'll unmute.
Yes.
Sorry.
Oh,
Texting
excellent.
is difficult, but yeah, no, absolutely. I'd love to build a passive house. I want to get certified and build my own and build for other
Awesome.
people.
Awesome.
And yeah, I mean, the presentation was great. I think it makes it sound simple, which it is, but I'm sure there's some complexity involved.
Well, the complexity is in the really in the systems that you're fighting against in order to get the project done. So the well-established ways of building things are being challenged by this building standard. That's really the challenge. That's the biggest deal. Less and less so, but that's really the biggest stumbling block. And yes, we can retrofit, Tom. You can retrofit to get to passive house. It's more difficult than building new builds, but you can get to just using the standard. Remember, it's not about certification. It's about getting the buildings so that they are using less energy. It's so important. Our buildings use so much energy and are really helping to promote climate change. 45%, I think, of the carbon that we use in North America is from buildings. And the buildings, it's the easy thing for us to do is to make our houses and buildings much more comfortable, more pleasant to live in and be in, and help and have them so that they're not destroying the planet, instead helping.
Yeah, Peter Amarangan, who was on the call briefly, but looks like he dropped off, is doing basically what's called a deep energy retrofit, a panelized option for deep energy retrofits with Butterwork. The company is working with in Edmonton. Peter Darlington is doing deep energy retrofits in Calgary. So somewhat surprisingly, actually, Alberta is somewhat leading, at least Canada, with the deep energy retrofit for single family homes. Because yeah, I think it's 70–80% of the houses that are going to be here in 2050, when supposedly we all need to be decarbonized and net zero, are already built. So yeah, we can't build new our way out of the problem. We have to find a way for retrofits. So the passive house retrofit standard is called EnerFit. It uses the same energy model. It's actually kind of the same process that Kim says, is you starting with the goals and then you work your way through. So depending where you are as a client, as long as your goals are strong and you are committed to that goal, then you pick the team to figure out all the details. But you don't need to work through all of them as long as you are the client and you are committed to those goals and you make that clear to the team. Alrighty, we're coming up on the hour. So anyone else had any other questions?
I had a question on mechanical complexity, and I share your goal of making it as simple as possible. And the simplest thing, of course, is just to go with electric heaters. But my oily friends constantly remind me that anyone who does that is adding to the peak demand in the Alberta grid, which already peaks in the winter. And how we avoid this is just a challenge. The air source heat pumps, again, seem to have their least efficiency and revert back to basically resistance heating when you need it the most, when it's 30 below. Any insight on getting around that conundrum?
It's an argument that is used just to make this all seem like it's not useful, and that's just not the case. So yeah, these are things that we can't get around. That it's just the way it is. It gets cold here in the winter, and it's dark, and the sun isn't shining as much. We're looking at the building over the year. We can produce a heck of a lot of energy in the summer. Storage is the issue. If there was a better ways of storing the energy, then we would have less of a problem. Electric baseboard heaters are the least expensive, least offensive, easiest, cheapest thing that you can do for heating a house that just needs a couple hair dryers for heating. That's, if that's the energy that you're looking for, that you need in order to heat the building, then electric baseboards are the answer, or something similar. And you can keep the heating complexity down for the building down to $1,000. Peter Amarongan again has done this in a project in Edmonton, where all there is some electric heaters under $1,000 for doing all of the heating system. One of the problems we have, though, is our heating up climate planet is that, and I guess it's climate, is that we need cooling. We need to have some cooling. So that's where the heat pumps come in, and that's where they're going to become necessary. So all of that ramble about the baseboard heaters, it's a good one, but we still are going to have to think about cooling and what that looks like, and air source heat pumps seem to be the way to go with that. And I think Mark has a question.
Yeah, I'll just jump in quickly, Mark. The other part of that is, the first thing you do is you reduce your demand by 80 to 90%. And once you've done that, then if everyone does that in the whole province, then we don't have a peak demand problem. So once you reduce your demand by passive house to 80 to 90%, then how you produce that energy, whether it's straight resistance or a heat pump, the grid can handle it. But you first have to reduce that demand.
I think those arguments are like red herrings. They lead you down a path that's not necessary. That's not the objective here. The objective is to reduce the demand, just like Frank says. And Mark has a question.
Yeah, I wanted to ask about foundations, especially in the instance that you have, and mind you, I missed the first 25 minutes of the presentation. If you have first of all, you just have your general foundation. You might have something that goes into the ground. You may have something slab above grade. You may, but a portion of your foundation also usually frost wall is above the ground. And especially if you're thinking about something like we are, a barn dominium, where you're going to have your whole first floor be basically foundation above ground, possibly. Are there ways to, are there any passive house principles or materials or anything like that that make foundations and cement work, like frost walls and above ground cement work, more energy efficient?
It's getting pretty technical, but a floating slab is the easiest way to insulate concrete. But you can also think about a wood foundation, and even a shallow foundation with wood and have concrete in between the wood foundation walls. And a frost protected shallow foundation is what I was just, a floating slab or a thickened edge slab is the easiest way of doing that. But having had experience doing that, and dealing with contractors. When this is what it's all about, making sure that everybody's comfortable with what they're doing on site. A lot of contractors aren't comfortable with it. They just want to do a frost wall. And there's a lot of reasons for that. Some of it has to do with site conditions, not really knowing what kind of fill you require, what kind of compaction you have underneath the foundation. So everything is site specific, especially when we're talking about anything being custom. So that question isn't really easy to answer, Mark. It's just, it depends.
Thank you.
It
But
depends.
there are
but
options.
yeah, there are options. It definitely has been done. If you're rural, generally building below grade, any type of basement, if it's not a root cellar, is not cost effective. You have lots of land, so some type of shallow foundation or frost wall, but slab on grade is your most cost effective. If you're in an urban where your land cost is a lot higher, then building a basement is justifiable. But in rural areas where you have acres of land,
and it depends on flood conditions, and it depends on the site where rainwater runoff or rainwater management may be an issue in terms of your basement. There's a lot of factors that are site specific.
Yeah, but has and can definitely be done.
Mm-hmm, mm-hmm, mm-hmm.
What was that? I'm sorry, Frank.
Just it has and can be done. It has been done
okay.
before and can be done.
Thanks.
Okay, we're done. 1 hour.
Anyone else? Yeah. Anyone else have
Awesome,
any
you
questions?
guys.
I guess we will thank you for coming today. Join us again in 1 month's time, at same time, same Zoom logins for it will be Silex fiberglass windows. So we can learn all about those high performance windows that they offer. I will end the recording now, but stay on for a few minutes if anyone else has any questions.